The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone, and thank you for joining our webinar and spending a part of your Friday with us. My name is Susie Ratzavong, and I'm the Communications Director for MindStream Analytics. Today's webinar is Data Transparency and Governance in the Analytics Supply Chain. Before we start, just a few housekeeping items. To confirm that you can all hear me, please click on the Raise Your Hand button now. Great. On the right side of your screen, you'll see a Questions tab. At any time during the webinar, please enter any questions that you might have in that box. We'll address all questions at the end of the webinar in the order the questions are received. Finally, for your information, this webinar will be recorded. In addition, I'd like to, of course, give you a quick overview about us. MindStream Analytics, headquartered in Boston, is a leading consulting and managed services provider focused on helping companies solve complex data challenges, improve business analytics, and optimize business performance. Our experienced consultants and professionals are here to help you align your business and technology needs with ease. Today, we collaborated with our newest partner, Lavastorm Analytics. Lavastorm is a global enterprise software company that provides a solution which will rapidly unify disparate data to deliver actionable insight faster. With that, I'm going to turn the presentation over to Dan, Lead Technology Evangelist at Lavastorm Analytics, and we can begin.
Thanks, Susie. Thanks for joining, everyone. As Susie mentioned, my name is Dan Donovan, and I'm Lead Technology Evangelist for Lavastorm Analytics. So today's topic, data transparency and governance in the analytics supply chain, really comes about because of the idea that the analytics supply chain is somewhat broken in a lot of organizations today. And there have been several disrupting factors that have happened over the past few years that have contributed to an overall sort of breakdown in applying traditional methodologies to how analytics projects get done today. These include things like, of course, the big data revolution with the associated increase in variety and volume of data, the velocity of data, and then really the velocity of analytics projects that need to be done. I mean, there are a lot of C-level executives today who are differentiating their offerings across entire businesses based on incorporating more analytics into the way that they make business decisions as opposed to the competition. This has led to a kind of consumerization of IT skills in some way and a drive towards more self-service within the business, which is driven by a shortage of data science and computer science skill sets that are really necessary in today's environment in order to access all of these new data sources and to produce useful analytic results. We see it as kind of a supply and demand problem, right? So you have IT being traditionally the supply side of the equation with requirements for control and governance, the ability to still maintain control over data sources, and to understand and enable the way that people are able to use those data sources in a consistent, transparent manner. They're facing limited resources and budget and a massive demand from the business. The number of analytics projects and things that would traditionally require these technical skill sets has just rapidly increased over the past few years. Looking at it from the business perspective, there is a desire for the ability to do these projects on a more agile basis without always having to wait through the traditional kind of life cycle of these projects, which I'll talk about in more detail in a minute. There's also pressure on the business side in a lot of industries through growing competitive and regulatory pressure, and a lot of rapidly changing requirements around the types of questions that people want to ask and the data required from source systems in order to answer those questions. To simplify that view a little bit, there are some driving forces on the IT and supply side in that the bottleneck around technical skill sets and the requirements for governance are really the key factors that are causing this to be a difficult challenge for IT to address. They want to enable self-service, and they want to allow the business to have access to all the data that they need in a timely manner, and to be able to produce results that are still relevant and actionable by the time they get them. But the question is, how can they do that and still maintain the integrity of the data that people are working with, so that you're not getting different answers from different people within the business to the same question. They're also a little bit afraid of this becoming the next Excel problem, where all of the logic of the analytics of a business are buried in places that are not governed or maintained by people who understand the technical solution. And so how do we avoid that and some of the mistakes that we've made in the past? Again, from the business side, the demand for analytics, they, in most cases, want to enable analytics as a self-service function as quickly and as broadly as possible, to be able to, in an agile way, rapidly develop and deploy analytic solutions. I mean, the real goal here is to be able to answer as many questions as rapidly as they can be asked from the data. And again, rapidly changing requirements, so that the traditional supply chain here doesn't always provide an answer or even provide the data necessary to get an answer before the requirements change. And so you end up sometimes in this endless cycle, which looks something like this. So in the traditional approach, it's very much what people in the software world call a software development life cycle for producing analytic results and answering questions from the business. So on the right-hand side here, you have business users who are the traditional consumers of analytic results, and the people with the questions that need to be asked of the data and answered in order to gain insight into a business process or in order to make a business decision. They would typically spend a lot of time gathering and documenting requirements, and then throwing those requirements over a kind of wall to a completely disconnected technical team, who would then develop some technical solution to address those requirements. Typically, they would get things right, about 70 to 80% right on the first try. And then you go through long cycles of testing and more requirements gathering and changing those requirements, pushing it back to the team that's disconnected from the business problem, and they would refine the results and push those back to the consumers. And so you have these two disconnected teams, the producers on one side and the consumers on the other side, and the business reason for asking the questions is actually quite far away from the technical solution to those questions. So this results in, it can result in a long time to market for these things. So it's not atypical in this sort of environment for a person in the business to ask a question of the producers, and for the producers of the IT department to come back and say, sure, we can get you that answer. It's going to be 9 months from now, and the internal cost will be several $100,000. And this is not because IT wants to be difficult. It's just that that's what it takes in this kind of environment, and there's a long queue of these requests coming from the business. And the velocity of those requests coming in has only increased and will continue to increase as more and more data sources become available, and as more and more people on the business side are aware of the types of analysis that are available today. This also reduces accuracy, because the producers are, in some cases, unaware or not intimately familiar with the business process or the business reason for asking the question in the first place. So while the technical solution may be very accurate and apropos to the question, it's to the data involved in answering the question, it's not always exactly what the consumers are looking for. This also results in a very high barrier to entry to getting analytics projects done. So if the person within the line of business who's asking the question has no idea at the outset what value they're going to get out of the answer, it's sometimes hard to justify the cost of even starting one of these projects because it's simply unknown and there's no way to prove that there will be a return on that investment. There are a lot of technologies today that are trying to solve this problem, or that are enabling people to solve this problem. And the way they're doing that is by bringing these consumers and producers closer together, at least in concept and in how these analytic solutions are developed. So now it becomes a more agile cycle of constant feedback of requirements into a solution that provides results. And the self-service aspect of this means that in many cases, business users can start to answer their own questions. And I'll talk a little bit about how the stack of technologies is evolving to enable that. But even in environments where it's not a purely realized dream of self-service, there are still ways to break down that wall between the producers and consumers so that the requirements, one, take up less time, and they produce something that is immediately relevant to the question at hand. So this, of course, reduces the time that it takes to produce these results. It increases the accuracy and transparency because the people closest to the business process or to the business problem or to the question that's being asked have a direct way to influence the solution rather than the compartmentalized requirements gathering and then testing and then change requests, that sort of process. You're starting to see a compression of that process and with much more direct involvement from the people who understand the business requirements. So this lowers the barrier to entry because the incremental cost of doing a new analysis is much, much lower than it is in the traditional model. So people are able to do this kind of data discovery work and understand if there's value in a set of data very, very rapidly without making the huge investment in bottlenecked IT resources in order to even discover if there's any value to be had in a given analysis. If we look at the way that the stack of technologies has evolved over the past few years and what's really enabling us to connect producers with consumers in a different way than we did before, in the traditional world, you had this idea of a business intelligence stack of technologies. And that generally involved source systems from all over the organization. And this is applicable not only to large enterprises, but even to small and medium businesses that started to build these data warehouses a few years ago. And the process would normally involve taking data from those source systems, employing a lot of very highly technical people in order to do some kind of ETL design, to design data models within the data warehouse to hold all of the relevant data, and then to build those ETL flows or processes just to get the data into that data model. And then an even more technical set of skill sets required to build a semantic layer or some advanced analytics on top of that data warehouse and that rigid data model. The idea being, or the dream of the data warehouse being, to build a single source of truth that then anyone in the organization who's looking at results from that single source of truth would be looking at consistent data that's been curated in the right way, so that the lineage of that data is well understood. On top of that advanced analytics and semantic layer, then you had reporting solutions and technologies that would allow you to build static reports. Again, it took quite a technical skill set to be able to develop those reports because you're writing queries against the data warehouse and then incorporating that data into the visual charts and things that people actually wanted to look at. You could combine those static reports and some ad hoc reporting functionality into dashboards, which then became sort of the gold standard of how people saw the information that was really relevant to them. So what's happened in the past few years is that a lot of emerging technologies at the time, from companies like Click and Tableau, products like Spotfire, they took the top of this stack and moved this over into the business. And it sort of morphed into something that became known as self-service visualization and data discovery. And this was really a revolution in the way that people interacted with data, because no longer are you looking at static reports, You're looking at dashboards and the ability to do ad hoc analytics in something that's a much more dynamic and exciting environment for working with data. So rather than just looking at tables and static charts, you now have a way to interact with that data and to really answer a wider variety of questions through a visual interface that's intuitive and easy for people to understand. So what we're left with now is that's great for the top of that stack. There's this bit in the middle now which has become kind of the new bottleneck, or this is still a bottleneck in the whole analytics process. This idea of taking data from source systems and putting it into a data warehouse or some other kind of highly structured, controlled environment, so that what people are doing with those visualization tools is at least coming from a single source. The problem is that the more data sources that are available and the more intelligent questions are coming out of the business because of this whole self-service data discovery functionality, the harder it is to fit everything into a structured data warehouse. Is being introduced which don't lend themselves very well to this idea of a rigid data model or a structured data warehouse. And so what's happened is there's another group of technologies that has emerged that allow us to kind of split this function into a couple of different areas, right? So part of this functionality for many types of analytic projects, this can now become a self-service function over in the business as well. We're not saying that it replaces by any means the infrastructure and the requirements for having a data warehouse and an established ETL function within IT. That requirement still exists and will for many years to come. There are lots of types of data and types of questions that can and should be answered consistently in that sort of environment. But for a great number of the analytics projects that happen today, there are technologies that can enable this to become a self-service function, and that function is being termed by Gartner and other analysts as self-service data preparation and advanced analytics. And so this frees up IT resources from always just being the data provisioners or the analytic sort of center of excellence for the whole business, and they can focus on things that they really want to be focused on today. This makes data sources available across the business more directly, but also allows IT to focus on real innovation. And a lot of the projects that are going on today that are truly innovating the way that companies work with data overall include, Hadoop and other big data kinds of technologies. There are a lot of these data virtualization technologies, and this idea of a static data warehouse or a rigid data warehouse on the IT side is evolving into a kind of virtual warehouse where you have data coming from all over the place, different types of sources, some structured, some unstructured. And this self-service data prep and advanced analytics layer within the business can give people within the business more direct access, not only to the traditional data sources and sometimes directly into source systems themselves, but also to these new data sources in a way that that can still be, importantly, can still be governed by IT processes, and so that IT is not losing all control of how people are working with data, but they're enabling people to do a lot more on their own without constant requirement for support from those technical resources. So we think about the difference that this makes in the way that analytics projects typically happen. If you look here, we've got the dark blue functions here in this process are things that are traditionally done by the business and the data analysts within the business. And then the lighter blue are functions that need to be done by a more technical IT or development kind of skill set. So in the traditional analytic development process, you had requirements definition feeding into the data preparation and analytic modeling that was done in IT, and then testing, which was usually a joint effort between the technical resources and the business resources, feeding back into more requirements definition and then that disconnected development of data prep and analytic modeling and more testing, and that cycle could repeat several times, and then a combination of IT operationalizing those analytic models and the business acting upon decisions that are made based on those analytic models. This idea of maintaining and enhancing them to deal with changing requirements or changing data sets or evolution of that analysis in the future. These are typically projects that last months to years and cost hundreds of thousands of dollars or more in that traditional IT-driven environment. What these new technologies allow us to do in shifting that stack over is to really compress that time frame greatly. I mean, in our experience with customers, it's not unusual for this cycle to be compressed from months to years to literally to hours to weeks. You can see 80–90% time savings all the time in the time that it actually takes to get one of these models up and running and producing actionable results. The important thing and the real the revolution that's going on now, or the evolution that's going on now, is that still, when it's required or when it's desired, you need to have a way for IT to govern this thing and to understand how people are working with data and all of those things that need to happen so that a self-service environment doesn't lead to inconsistency, it doesn't lead to opaqueness or lack of transparency in how people are working with data. We don't want to end up in another world where everybody's got their own version of a spreadsheet, and the macros in that spreadsheet are what's really making the world go round, but there's no way to provide consistency. Everybody's been in a board meeting or in a boardroom somewhere where they're presenting numbers. Someone else gets up and presents different numbers, and the question from the CFO or whoever the executive stakeholder is, why are these numbers different? If the answer to that is buried in a lot of code, whether that's database queries within an IT environment or whether it's macros within a spreadsheet, it can take some time to pry that apart. Sometimes it's not even possible to reconcile why those numbers are different. So we're trying to drive consistency and governance around the way that people can employ this new self-service, agile way of building analytic applications. So how do we do that? There are really three sort of, you can think of this self-service function in the modern way as the intersection of three broad sets of capabilities. The first is enabling people to do their own data preparation. So, the technologies that are out there that do this well today consist of drag and drop visual tools, usually in a data flow or workflow sort of paradigm. So you're taking data from source systems, and they should be able to take data from wherever they want, whether that's something that exists in a database or a data warehouse already, or maybe it exists in an Excel spreadsheet, or it comes from an ERP system or a customer system. Maybe some of it is in cloud-based systems. Some of it could be in unstructured big data sources like a Hadoop data store or other kinds of NoSQL or those types of sources. Could be more complex and technical things like binary file extracts from old COBOL-based systems that are still around, or any type of data, really. You should have an easy way for people to access that data and to bring it all together into one integrated analytic environment without writing code and without having to have a data scientist or a computer scientist kind of skill set. So this helps to build a strong foundation, and if you do this correctly, then there's a way to do this in a governed way so that people are consistently using that data. So it's no longer the rigid structure of the enterprise data warehouse as a single source of truth, but rather it's curated sets of data and curated ways of accessing that data that allow people to do it consistently, but to do it on their own. This leads into a self-service advanced analytics function. So a lot of these technologies have tools or things that you can do with data that would traditionally require a very technical skill set. So this could range from things that are as simple as reconciliations between different sets of data from source systems, all the way through to complex predictive analytic models that have been written by data scientists, but now need to be accessible to the non-data scientists within the business. I mean, an example might be someone in a sales department who's responsible for sales forecasting. Maybe they want to use, or they've been told to use, an ARIMA model for forecasting sales. They don't need to know the inner workings of that ARIMA model, but they should have an interface available to them so that they can specify a few parameters and they can get the results of that ARIMA model, which is what they're really interested in, just as one example. The idea here is to have a subset of more technical users who are building things that can be used by a much broader audience of less technical users in order to get analytic projects done, in order to get results that are actionable. And if you're doing this correctly, then it should also be able to integrate into the existing environment. So ways to affect changes in external systems sometimes, or at least to connect with those systems in a native sort of way for querying data, or for pulling results, or for providing ways for people to take action, those sorts of things. And then that self-service data prep and advanced analytics layer also needs to be able to publish things out and publish results out in the way that people want to work with them, right? So if this were just producing another database or another sandbox or another data warehouse or data mart within a department, we haven't really solved the problem. You need the ability to push these results out into the applications that people actually use for hands-on working with data. In a lot of cases, those are the new generation of visualization tools like Qlik and Tableau and Spotfire. A lot of people still use Excel for that, so that's a valid use. You do need the ability to write back into a database or a data warehouse in a lot of environments. I mean, almost every environment still has that paradigm out there, even for end users or for business departments. And in a lot of cases, we're still interacting in this self-service data prep world. We're still interacting with traditional reporting stacks. So people are still using products like Business Objects or Cognos or those kinds of things. And so it's important that you don't lose the continuity of dealing with the end user interfaces that people are used to working with. So the real crux of this is all great that we can enable this, but how do we do it in a way that keeps everyone happy? So the idea is that these new technologies provide ways for IT to be happy, and that people are using things in a governed, consistent way, and for the business to be happy that they can do things independently of constant support from IT. And so, this is really driving two sorts of cycles here now. So the new world looks like this. On the left here, we still have producers. That producer needs to be a less technical producer than it was before. But in some cases, you still have slightly more technical kind of power users who are creating functionality that's meant to be used by a much broader audience of consumers on the right. And the cycle that happens is that these things can be created, but then they need to be curated. And what I mean by that is they could be put into some kind of repository that's controlled by user and role-based security. And especially in large enterprises, importantly, to integrate with the existing security framework, something like an LDAP repository or those kinds of things, to drive which people have access to view these components, to use them, and to modify them. And those are three very distinct roles that people need to be able to have. But this, if it's done right, leads to governance and much more reuse of functionality than in the traditional model. They're essentially creating building blocks of analytics that people can then drag and drop and connect together. And if those building blocks have already been tested and they're curated in a way that limits access to the right users and the right roles, then that really leads to this idea of governance, right? From the consumer side, the building blocks can be assembled into analytic applications that deliver valuable results so that they can analyze and visualize data based on their need. And so, as I said, some consumers would have the ability to just view these models so they can understand. You can imagine someone looking at a number in a chart and asking, where did that number come from? If they have a visual way to look back and see exactly what happened to that data, that particular field or that particular set of fields within the data that they're looking at, you don't have to really understand how all the technical plumbing is working underneath. Just to be able to see that flow is helpful in a lot of cases. It also helps with other governance functions or audit functions like internal audit. If you have a documented trail or history or lineage for each piece of data that's in a critical report or dashboard, then it's much easier to validate that that number is in fact accurate and correct. So when you get this right with the right combination of technologies, it really enables this idea that's become sort of the analyst buzzword over the last 2 or 3 years for what this environment should look like in the end state, and that is the idea of governed data discovery. So all the benefits of a data discovery environment in that people can look at data, get their hands dirty, so to speak, and really explore what the data are telling them. In order to drive more valuable analytic applications that are producing more valuable and actionable results in this ever-changing environment, but in a way that is governed and consistent. And so that's the kind of the holy grail of self-service analytics. I'll talk about one case study from one of our customers where this idea was applied on a very broad scale. So this customer is a large investment banking group, and they have a process whereby anyone within the banking group can submit a web form, which is a data request. So it may be something like, I need to see this billing data for this subset of products within this date range, and I need all of the currencies involved converted to US dollars for consistency. And so in their traditional process, what would happen is that they had a team of ETL developers who would take that data request and look at the appropriate source systems, design an ETL model, implement that ETL transformation layer in their ETL platform. That would push data into a database, and then they had a QA team that would test the whole thing to make sure that the data were accurate, that the transformations and all of that were correct. And then they would take that and push it into another database, which was a sandbox environment, so that the person who requested the data in the first place could then go access it through that sandbox, which in their case was a Microsoft SQL Server environment. So that left the person who had requested the data, they still needed to understand how to access that data in a database, and in a lot of cases they were pulling it out into spreadsheets, and they weren't really sure what they were doing with the database, but that was the process. So normally this took obviously quite highly skilled resources. In this bank's case, most of those resources are located in New York and London, which makes them quite expensive teams. They don't have enough of these resources, so these data requests were taking up valuable time away from more innovative and more critical IT projects. And they really wanted a way to make this function something that could happen on its own with less involvement from those technical teams. And so what they do now, they've implemented this with an agile, self-service data prep and advanced analytics tool that comes from Lavastorm. But the process now is that there are some power users. They may be even members of that same team that used to do the ETL development for this. But they build a library of building blocks. So in the example that I gave where someone requests billing data for a certain date range, and then with a currency conversion step in between, there's a block now that's been designed to access that billing data, and it has some parameters on it that allow someone to specify a date range and a subset of products, and they run that building block and it produces that set of data. And then there's another block that performs a currency conversion. So they just plug that in and select the currency that they want to standardize everything on, and a date, or whether they want to use a date field within the data to find the currency rates for that day. They can just plug that in, and that produces the set of data with the currency converted, et cetera. So these blocks themselves go through the QA process. So every set of data coming from that billing system no longer needs to go through QA on its own. The way that the data are being provided has already been tested, and so you cut down the involvement from these technical teams to really just the building and testing of these building blocks. They then have a set of less skilled data clerks who are actually in an offshore team who can assemble these things. So they get a ticket in their ticketing system that is the data request that's been submitted. They're then able to drag and drop these building blocks that have already been tested and that are curated in a way that only the right people have access to them. And they build a model which requires no scripting on their part, limited configuration. They're really just filling out the parameters on these building blocks that correspond to the items that are in the data request. And once they've done that, they can push that data out into a lot of different formats that the people requesting the data really want to see it in. So they can push it out directly to Tableau or Qlik or Spotfire. They can still push it into that SQL Server database if that's what people want. They can produce Excel spreadsheets, or they can populate existing Excel templates and models. Really any kind of format that the person requesting the data wants to see. And there's a checkbox for each of these formats that are available to them, and that's part of the data request. Once they've built this model, then they can attach it to that ticket. And if the same person or even a different person requests the same set of data next month with just a different date range, for example, then the data clerk can just pull up that ticket from before, change the date range. The model is actually attached to the ticket, so they don't even have to build the thing from the building blocks again. They can just rerun it and produce the data straight away. So the impact of this is that the average time to fulfill one of these data requests went from 4 weeks in the traditional method to about 4 hours using the new method. And in some cases, it's even faster than that. If the model already exists and it's stored with the ticket, they can rerun it and produce the data in a matter of minutes, depending on the queue and the size of this data clerk team that's available to address these things. The cost, obviously, is much, much lower. These are no longer $80 an hour or $100 an hour resources in New York and London that need to be devoted to this, but they have a set of these data clerks that are maybe $10 per hour people in offshore locations who are able to service all of these complex data requests in a way, again, that has a lot of governance and control around how the data are being provided, so that it ensures consistency, it ensures transparency. Another big difference is that the consumer of that set of data can now also see that visual model and understand exactly where their data are coming from. So they can validate themselves that, yes, this is the right set of data for the analysis that I'm trying to perform. So through a combination of technologies that have emerged over the past few years, there really are ways now to enable this idea of governed data discovery and governed self-service analytics in a way that sort of keeps everybody happy and out of each other's way. And so that's really the point of today's conversation is there are finally ways that we can do this without it getting out of control and disrupting the integrity of our enterprise data. So with that, I'll hand it back over to Susie to wrap things up.
Thanks, Dan, and thank you all for attending today. We're going to be sending an email with a link to the video. as well as an opportunity to retrieve the slides from today. If you have any questions or problems regarding that in the next week, you can reach me at marketing@mindstreamanalytics.com. We'll now address any questions you have from the question box as we receive them. I don't have any right now in that box, but if you want to take a minute, we'll give everyone a minute maybe to maybe gather your thoughts. It was just so overwhelming. And type in your questions. Well, it doesn't look like we're going to get any questions today, but no worries. Thank you all for attending. We hope to see you again soon for a monthly webinar. We'll do another one end of August, the last Friday of August, and we'll hope to see you there. Have a great weekend.